What we'd like to do in this segment is look at enterprise wireless security, hardware security. What we're going to look at is some enterprise type devices. This is chapter 6 from the book that we're using, which is Wireless Security by Mark Ciampa. So the objectives are listed and describe the functions of the different types of wireless LAN hardware in an enterprise. We'll look at some of the devices that we use in an enterprise to hopefully make it a little bit more secure than our home wireless network, because somebody may be wanting into it more, so probably a bigger target than our home network. Tell how access control and protocol filtering can protect a wireless LAN. Access control, who can get on it, who can manage it, those kinds of things. Protocol filtering, what are we going to filter to firewall? Are we going to have the firewall configured? How many firewalls are we going to have? And where are we going to put the wireless access point relative to the firewall itself? It's kind of an interesting quandary as to how we would actually do that. The functions: quality of service, handoffs, power features, wireless networking hardware. Quality of service, what gets the highest priority, and if we have a voice over IP, obviously we want voice too, because probably there are some things, but one of the things that can get you into trouble really quickly is when the boss's phone calls start to drop as they're roaming. So, and that's what handoffs are all about. Power features of the wireless networking, voice, power over Ethernet, so that we don't have to actually have plugs, because we tend to put some access points into really odd places, like where there is no outlet. Also kind of handy if you have your phones running that way. You don't have to worry about taking a power outlet for the telephone itself. It runs from the power that comes from the power over Ethernet switch. Some examples of WLAN hardware: wireless local area network hardware, access points, remote wireless bridges, wireless routers, wireless gateways, wireless switches, wireless mesh routers. So what we want to do is take a look at each of those quickly individually, so that you kind of have an idea of what these things use. The access point has an antenna and a radio transmitter, receiver, to send and release signals. And as we talked about earlier, send and receive signals. As we talked about earlier, an access point is not a router. It doesn't change the protocol, doesn't forward the IP address. It simply extends the distance of the network. An RJ45 wired interface that connects into the wired connection, the wired network. And special bridging software to interface wireless devices to the other devices. If you think about it, the access points and the wireless routers are pretty sophisticated little pieces of equipment, because they take the wireless protocol and convert it into a wired protocol. Same thing happens other way around if you're trying to connect to a wireless device from a wired connection. So it is a pretty sophisticated piece of equipment, if you will really think about what it does. The basic function: acts as a base station for the wireless network, acts as a bridge between wireless and a wired network. It allows the wireless and the wired to connect together. And the range depends on the type of the wireless network. Obviously, walls, doors, all those other solid objects are between you and the end of the world. How far can you go? And most of the distances, keep in mind, that are advertised for these devices are unimpeded distances. If you go out into an open field, you're not trying to go through cement walls, or through 3 floors, from a second floor to a basement, or from a third floor to a basement, or from a first floor to the 10th floor of a building, of a hotel, or those kinds of things. So all of those impediments are going to affect how far the system goes. Number of wireless clients supported varies, and it's going to vary based upon the access point. Here it says theoretical 100 clients. I've seen a couple of them says theoretical 250 clients. Light traffic 50 clients, heavy traffic 20 clients. Keep in mind that in Ethernet we use CSMA, carrier sense multiple access collision detection. This system uses collision avoidance, which means that when a station is transmitting, it has the full attention of the access point. Now 802.11n modifies it a little bit, makes it a little bit better because it has multi-input, multi-output. It has more than one, can have more than one device connected to it at a time. It has multiple antennas to allow that. But generally speaking, for anything before that, when you connect to it, you own that connection. You own the access point until your connection is done. One of the great ways, good ways, best ways, easy ways to kind of jam up an access point is go watch a movie, because you'll have the access to the wireless, and you will generally keep the access to the wireless. The access point, again, that we've looked at this before, and the issue here becomes that we go in here, we just have the single, because I got the wrong tool, I want a freehand, a single connection, a single Ethernet connection. On a router we'll have probably 4 Ethernet connections, as well as a WAN connection that allows us to connect to the internet. So this device, again, simply extends the range of the network to the wireless devices. This is a diagram of access point on the network, what one of these things might look at when we do it. When we have it here, we have our access point here, and it's connected to a router. It is not a router, and we have all these other devices connected to the router, and this is obviously a layer 3 router because it's got a lot of ports here. So we have our wireless devices connected to the access point, which then allows them to connect to the wired network. So access point different from wireless router. Access point extends the range of the network to the wireless, or offers the opportunity for the wireless devices to connect to the network. A remote wireless bridge connects 2 networks together. If you remember what a bridge does, it segments the network in an Ethernet, particularly busy segments. This is a division at layer 2, which means that if we have these things, then we will be able to have the switches memorize the MAC addresses. And when we do that, they're only going to allow the MAC addresses to go from one bridge to the other when it's absolutely necessary. Using the MAC table, if the address is on the switch that the device is connected to, then it'll simply forward it out that port. To illustrate that, let me bring a packet tracer file in here. We'll look at this thing briefly with packet tracer. What I've done is I've got 2 switches. A switch, remember, is a multi-port bridge, and we connect them together. We have the trunk port here, which allows everything on it. The bridge is going to create a MAC table whereas it's going to memorize all the addresses that belong to a particular port. So what it'll have is, for all of these addresses, it will have the MAC address in its table, in its MAC table, that says that if they are on this side of the bridge, they don't go across the bridge. So we reduce the amount of traffic for these things. Same thing over here, that we have now segmented the network, and we've segmented it at the broadcast, or excuse me, at the collision domain layer when we do those things. So we do the same thing with wireless, with the wireless bridge. We want to bridge networks together. Instead of connecting them together with wires, we want to do them wirelessly, and a wireless bridge, I've seen different numbers, 10 kilometers, 3.5 miles. So it's not like we're going to bridge these things together at 100 meters. We can bridge them together at greater distances. Connects two network segments together, can be used, and the segments can use different types of physical media in the software for transmitting and receiving signals. So when we look at this thing, a wireless bridge connect two or more wired or wireless networks, transmits at higher power than access points, and a number of the access points, particularly the Cisco equipment, you have the option of making it an access point, or making it a wireless bridge, or making it a repeater device. We'll talk about it again in a little bit. Uses a highly directional or a semi-directional antenna, usually concave, the dish shaped, that are used for point-to-point or wireless links, and a wireless bridge can be a point-to-point or a multi-point sort of thing. Semi-directional antenna focuses the energy, and if you remember when we talked about earlier, there is so much energy. In an omnidirectional antenna, the energy is going to be less. As we focus it, the more focused we make the beam, the higher the power, because all of the power from the access point, instead of going in all different directions, is now focused in a single direction, so that the power actually increases with these things. Short to medium range bridges. This is bridge antennas, what the antennas would look like. Focused antennas from point A to point B, and a wireless bridge here, and this is just showing that we are going to have some distances. This is some separation, some airspace separation, and we're connecting one to the other. And these networks, you notice that this network here on the left side, 192, 168, 1.245, and this one is 1.246, so they are on the same network. And this just shows that you can have wired or wireless, doesn't really matter. What we're doing is segregating the network, sending information back and forth from one side of the network to the other. Picture of their drawing of what a semi-directional antenna pattern would look like, and we can make it more directional depending on how much you want to pay for the antenna, and that's going to be what's called passive gain in order to increase the power. The remote wireless bridges, the delay spread, minimize the spread of the signal so that it can reach farther. Again, we're going to have the signal more focused so that we have more of the energy, or the energy all concentrated in as small a point as we can. The wireless bridges have a point-to-point as well as a point-to-multi-point capability, which means that we can have here point-to-point. If we want, we have the two access points here, the point-to-point file server on one side, file server on the other side, PCs. If we need to get there, we can go from one network to the other. Point to multi-point, no real difference in the concept here, except we have a remote wireless bridge here, and it's connected to these other two bridges. So we've connected, instead of two networks, three networks together. And when we do this, one of these is going to be a root bridge and the others are going to be non-root bridges, and so that they can connect with each other. Wireless bridge modes: access point. Root mode acts as the root bridge and can communicate only with other non-root bridges. And we can have a single root bridge. So we have a root bridge that connects with our other non-root bridges. And that then will allow us to have our multi-point. So the root connects to the non-roots. The repeater mode extends the distance between LAN segments, and this is wireless repeater. The issue with repeaters is that when you add them, for every repeater that you add, you basically have your speed, because every packet has to be acknowledged in a wireless system. Remote wireless bridge again, and this is remote wireless bridge in root mode. Get my little arrow back here. So this one is root mode, and these other two are going to be in, or this other one is going to be in non-root mode. Saw all these little wireless symbologies here, and I just, for some reason, saw more than one access point. So a root, a non-root, one root, one non-root, in order to make those things work. And this is a remote wireless bridge. Again, we're going around the world. More pictures, probably a good thing, but we have root mode. This one's in repeater mode. You notice it doesn't have any clients connected to it, and then the repeater sends it to the one in non-root mode. So repeater doesn't have any clients connected to it. The bridges do. They connect to the network. Repeaters just simply repeat the signal. They don't have anything connected to them. Remote wireless bridges, cost-effective alternative to expensive lease lines are trying to lay down. The cities don't really like for you to dig up their streets. So we are able to send a signal from point to point, and there are calculations and things you have to worry about, like trees growing up, buildings in the way, things that can affect what goes on with your system. If you wanted to go across the Grand Canyon, for instance, instead of trying to run fiber or something like that, you could use wireless. If you wanted to go between two buildings in a city and you have a line of sight, you could connect these two things. But keep in mind that, again, we're still using the unregulated frequencies. And if somebody puts up a bigger, better antenna or puts it in front of yours or something like that, there's not really anything you can do about it, because it's an unregulated bandwidth. So these things here, they say that we can go up to 40 kilometers, and they say in this slide that 11 megabits per second. If you'll go look on the internet, you'll find that the 802.11n bridges are operating 300 megabits per second. So you can go relatively fast with the newer, much faster than this obviously, with the newer protocols. The wireless router transfers packet between networks, selects the best link. It's a router just like a wired router, except for what we're using at layer 1. And in these things, you're probably going to have a wired component and a wireless component. Most of the home routers come with like a 4-port switch and then a wireless to connect to the WAN port for the routing. Combines the access point with a router, typically with multiple ports like we said. The advantages: connect multiple networks, improves the network performance, shares a single IP address if we're going to PAT. The term that we usually use is NAT, but in a true NAT, if we're actually NATing, network address translation, we have a one-to-one correlation between a private IP address and a public IP address. PAT, port address translation, is what most of us use on the internet. We have a single public IP address that we get from our ISP, and we do a port address translation. We translate our private address from our network to the public address, and then that conversation gets assigned a particular port. So when it comes back to the PAT table, it knows where to send the information back to. So PAT shares a single IP address. NAT has multiple IP addresses. And again, the router here, the difference between this one and what we saw earlier is we have the switch ports here and the WAN port here, which is going to go to the internet. And these are going to go to our private network, along with the wireless goes to our private network. Router, again, try arrows again. Here we have a laptop, wireless going to our access point. It then connects to the router, and depending on how we are actually got this thing configured depends on how we do things. And in this case, this network segment is 192.168.164 rather, and this one's on the 206. So this says an AP, but it's actually going to be a router because they're on different networks, different IP networks or IP subnets, so that we have to have a router to communicate between these things or among these things. We're now establishing not a collision domain, which we did with a switch at layer 2, but a broadcast domain by using the routers. So they've got to go through the router in order to get from one network segment to the other. Unlike the previous one, we didn't have a router, we only connected it at layer 2. This one connects a little bit higher layer, layer 3. Wireless router here, we have a lot of different devices. Actually, we don't have a lot of different devices. We have 4 devices. And again, we're down here, we have the 198.164 network and the 206 network. So the router here is going to send the information from one network to the other. And it does, again, broadcast isolation when we use these things. And that's what routers are used for. Routers find networks. So that's what we're doing with them. Wireless gateway acts as an entrance to another network. Basically, a gateway, when we configure gateway, it's the next router that we see. And when we configure router to router communication, the next hop is the gateway, and sometimes call the gateway in some of the devices. So it acts as an entrance to another network. The wireless gateway combines an access point, router, and network address translation. What we're talking about is our home wireless network or an enterprise level wireless network. And what we're getting into a lot there is the different kinds of security that they use and how many devices can be connected to it, VPNs, all sorts of extra services that are available. Enterprise gateway functions include authentication, encryption, intrusion detection, things we were talking about, bandwidth management, centralized network management. So authentication, can we do captive portals, for instance, we would use there. If you go to a hotel and you get on their network, you get a web page that pops up, and you may have to put in your room number, and then you agree that you won't do anything nasty on their network. We can use encryption. Intrusion detection can be done at the wireless gateway, the wireless router. Bandwidth management, quality of service, what we want to use, who may get more bandwidth than who may not. And then central management of the network, the management capabilities of these devices. A wireless switch, and this is just a picture that I found, and again, it's just kind of what we've been talking about before. We take an access point here, up here, and let me get my arrow back, maybe. We take our access point up here and then connect it to a router, the main router. And it's going to actually go somewhere. We connect these things, it's going to go to someplace else, maybe to the internet, maybe to another router, maybe to somebody else, someplace else on our network. So it joins multiple routers within one LAN, contains more intelligence than a hub. A hub is generally considered a layer 1 device, is a layer 1 device, and it doesn't do any traffic segmentation at all. A switch does traffic segmentation at layer 2, and a router does segmentation at layer 3. Types of switches: unmanaged switches don't have any capability. Those ones that no management capabilities of the switch at all, we're not going to be able to create VLANs, for instance, those kinds of things. A managed switch provides features of an unmanaged along with enhanced management, both control and monitoring of the network. How much traffic is going on? Is there a particularly busy port? Can we create VLANs? Those kinds of things we would worry about in a managed switch. One of the challenges is in an enterprise setting, it integrates management of wired and wireless networks. The wireless switch does. And it's often a rack mounted, performs user authentication and encryption. So we can do all of those things with the wireless switch. And it can actually, when we get to thin access points don't have any management capability. The wireless switch can manage these devices. Simplified with these are really basic access points, have no management capability. It's sent to them by the control unit, which is going to be a wireless switch. So the wireless switch, authentication and encryption, and my image was really kind of off because I had two wireless access points. When we look at this thing, the wireless switch is going to be this special device up here that if we had the lightweight access points, it would manage them. So some of the information, a full access point does everything on it. A lightweight access point, stuff goes to it for the anything except connectivity, authentication, things like that. It's going to go to the wireless switch, which will then do that authentication and encryption. The thin AP does no authentication or encryption, but it does have connectivity. It's a basic device that's managed centrally, and when you create these things, you create policies and manage all of them centrally using one policy generally. So the wireless switches simplifies the wireless network, eliminates handoff procedures because all of the management, again, for the handoff procedures is done in the wireless switch itself. Basically anything that requires intelligence or decision making is going to be in the wireless switch. The disadvantage: all thin access points and wireless switches are proprietary, which means that you can't mix two different manufacturers. The thin APs do not provide true convergence of the wired and the wireless networks. The 802.1v protocol 11 assists in the management of the WLAN devices. It does load balancing, automatic configuration, and helps preserve battery life of the devices that are connected to the system itself. Mesh routers, limitations of connecting to the AP via a wired network. Placement of these APs is limited. The access points have limited range, but they generally will find each other and create their own mesh, and as the signal strength changes, the configuration of the network may change also. Mesh networks, the earlier placement, and what the mesh does is solve those problems, the limited range, and it finds those things. The best example, they say, is the internet. Wireless mesh allows for multiple paths when we do these things. This is a picture again from the internet of a wireless mesh, and this one, if you'll notice, has very few connections to the wired network. Generally you're going to have one. This one has two because we've got kind of a backup path. We have one connection here and one connection here. Everything else is wireless, and we're going to have different paths to get around this thing. And if one device goes down, we still have other paths to get to each of the locations. So a mesh, multiple, everything's connected to everything else. In the wireless mesh, you simply allow the access points to become part of the mesh network, and they will configure themselves or set themselves up into a mesh network. Wireless mesh, again, the single path for the routers, the AP on the wired network. When we do that in a mesh, and this just shows lines connected, and everything again is connected to everything else, and that's what makes a mesh. Multiple redundancies that allows us to have paths that if one path goes down, if we have an issue with one of these things goes down, let's do a freehand here. If this one goes down, we have other paths to get around it. Let's see, we can go that way. That's gone. This one obviously still has a path to here. And again, if any path goes down, we have multiple ways to get from point A to point B. An expensive way to set up a network, but the best for redundancy. Adhocs allow greater distance away from the access point. Ad hoc is when we would use computers that in ad hoc mode in order to connect devices together. Each client device can act as a relay radio station for the signals in this case. Advantages: decentralized management. Decentralized management sounds like a really cool thing. As long as people know what they're doing, decentralized management is a good thing. But if they don't, decentralized management can cause you a lot of heartburn. Can decrease costs, and it can also be reliable. I didn't say it would be, but it can be reliable. So in this case, these things are connected. The laptop's out here. We have the one connected to the laptop, connected to the access point, which is going to allow us to go from, let's go back here. We can go from here to this laptop and this laptop to the access point. Or if we lost communication, we could go from here to here, here to here, here to here, here to here, and then to the access point. So lots of opportunities there if we use to extend the range, if we use the laptops in that role. Backhaul wireless mesh routers connects special access points known as wireless mesh routers in a mesh configuration. Provides alternative data paths to the backside connection to the internet. The backhaul is the connection from the routers to the internet. So what we're doing is we're connecting the mesh finally to the backhaul or to the router that's going to actually get us to the internet. These things, as I say, used extensively in outdoor municipal wireless LANs, can be quickly deployed in an emergency. Lots of emergencies, hurricanes, tornado situations. These things can set up. You can set up and get a network up and running, a wireless network up and running pretty quickly. And wireless is relatively quick compared to wired, especially quick to get set up. And again, more pictures here. Wireless mesh routers, a whole series of them that are connecting devices at a distance to wireless mesh here, wireless mesh here, and they're creating their own mesh that we eventually get one that connects to our wired network. And you only really need one connection to the wired network to work in a mesh, in a wireless mesh. No standards for the mesh networks. The 802.11s task force is working on the standards. 70 different wireless mesh routing protocols, algorithms, number of radios. What are we going to do with them? Hardware security features, access to hardware, and access is what we really are talking about, authentication and access, but who can get to what, who can use what's what we really function with in just security in general. on a network. Protocol filtering allows us to stop certain things in those. So access control restricts the user to accessing only the resources essential for his or her job. Your people in the network aren't going to like that because they think they should have access to everything or more than they have. What you need to do, have to do, is limit users to the resources that they need to do their job. Having done that for a little while, yes, I know that people will always want more access than you want to give them. Sometimes you have to give them more, but they need to show you that they need that in order to do their jobs. Limit access to resources based on identities and membership in various groups, and that's the way we do that discretionary access control, where we actually give the access, and that's what that one's all about. Mandatory is the most restrictive. User is not allowed to give access to another user. It's set up by someone else, administrator for instance. All controls are fixed in place and there is no flexibility in this system. It's used in military environments in a lot of instances, and one of the examples of mandatory might be that you have to be in a certain location, a simple one, in a certain location to use a resource. It may only be available remotely. Role-based. Administrators assign permissions to a role and then users fill that role. This is a great way, and you can do this in Windows with groups. And if you're using NetWare, it actually has a role object. But what you do is give the role or the group access to all the resources. And as somebody comes into that job, you put the user into the role, and then they have immediately access to all the resources that they need. So we determine the access that's required based upon the role of the individual. Discretionary access control is what you and I do when we give somebody access to a resource. In Windows, right click on permissions, and then we're going to add a user to allow them to get to a folder, use a printer that's on our desktop or something like that. Access to hardware, role-based, business manager role, account role, director of finance role, and this is just kind of symbology for what we've talked about before. You can have more than one user in a role if you need to do that. If you have multiple users that need access, the same access to do that. Protocol filtering filters traffic based on specific criteria, usually IP address and or port that is coming from, the service that it's running. So we have address filtering, data filtering, and protocol filtering when we look at those things. Some access points can be configured to filter unwanted protocols from either entering or leaving the access point. And don't sell leaving short. What do you or don't you want your users to be able to do? If you have filtering going out of your network and somebody gets infected, or a number of machines get infected, this can prevent you from becoming a member of a bot army, for instance, and becoming part of a distributed attack of some sort, probably a distributed denial of service attack. So don't sell that short. Don't sell proxy servers short, because if you use a proxy server, then you would block outgoing access to most ports from all of the devices except the proxy server, protecting yourself again from the sort of embarrassment that you might have if you became part of one of these armies. Can only be used in a few situations, and this is a picture, an image of from the Linksys, and the things that are available is going to be different on the different access points, and as they become newer, more things may be added. This one's block anonymous internet requests, and this is a firewall. This is coming into the firewall. Filter multicast, filter internet NAT redirection. NAT redirection, somebody may be trying to get onto your network, and then filter the ident port 113. different things that we can filter. And if you're using a firewall, you obviously have a lot more flexibility. A hardware or a software firewall, you can have a lot more flexibility on what you can configure to do that. Other features we've talked about: quality of service, fast handoff, and power features. Quality of service 802.11e was intended to be fair, not appropriate for real-time traffic. Quality of service capitalized to prioritize different types of frames. The task force, the new modes, the 802.11 MAC layer, enhanced distributed channel access, and a hybrid coordination function control channel, HCCA. What we're basically doing with these things is telling it which one gets handled first. And when we do that, we have the categories that we use: voice, video, best effort, and background. So we're going to use those. Provides a quality service, relative quality of service, but does not guarantee its service. HCCA is based on polling as a centralized scheduling mechanism. The Wi-Fi, WMM Wi-Fi Alliance quality of service specification is modeled after the wired QoS quality of service, which actually is a quality of service managed by the system. And it's a subset here, defines the arbitrary in-frame space number and condition windows, and this is the way it sets the system up. Voice is the highest priority, high quality of controls. They get 2 slots, the contention window 0 to 3 slots, and the time wait 2 to 5 slots. Video is going to be next. Prioritize video traffic so that the regular data, higher than the regular data but not as high as the voice traffic. 2 slots, contention 0 to 7, 2 to 9, as we go into these things. Best effort traffic from applications that are not time sensitive, and then in the background, low priority traffic such as file transfers or print jobs are going to go into the lowest category of the system. Handoffs, this is significant when we have roaming enabled, that we hand off from one device to the other. If we're using a wireless switch to manage the access points, it becomes a little bit simpler because it's going to do most of the management for us. The standards for these things, if you're going to use roaming and do this, then you need to be sure that all your access points are from the same manufacturer, because they may or may not work together. So exchange roaming information. A fast handoff, the voice over wireless local area network. Phones need a fast handoff so that we're not dropping calls when we're going from one point to the other. Allows the wireless client to determine the quality of service and the security that's being used at the different access point before it actually makes the transition, to be sure it's going to work. Power features, this is power over Ethernet. Typically the 802.11h is enabled to design to allow WLAN devices in the 5 GHz spectrum. Dynamic frequency selection and transmit power control, reduce interference, reduces radio transmit power. These power features, this is not the power over Ethernet. This is the 802.11h here, the 5 GHz spectrum. And what happens here is there can be some interference with some military radars. And if there is an interference, the access point reduces the power or actually changes the channel in order to not interfere with the military radars. And now we'll get to power over Ethernet. Jump a little ahead on the last one. 802.3 AF. This sends the power to the device over the unused wires on the Ethernet cable. The thing to consider when you're setting this up is to be sure that your switch is plugged into a breaker that has enough power. The switch itself will actually test the device before it sends it power to be sure it needs power. That prevents you from burning up devices that aren't power over Ethernet type devices. So it delivers the current across the network here. Reduce interference from the surrounding objects. Electrical power outlets are generally not found in locations where we put access points out of the way high, where there a lot of times aren't. And where I work, we use voice over IP telephones. The telephones are frequently at desks that don't have a lot of outlets are available to them after you get the computers plugged in. So power over Ethernet to the telephone, the device, the telephone itself actually becomes a switch, a little switch, a 2-port switch, to where we plug in the phone, and then from the phone we go to the computer, and each of them gets an IP address. So this is something that delivers power to the end device. Could be a wireless access point, could be a telephone, anything that has that capability. If we have failover support, we have duplicate equipment alongside the main equipment, that goes into standby mode. So in this thing, we've looked at these different devices that work at the enterprise level. Some pictures of each, descriptions of each, the devices that allow us to make the enterprise hopefully a little more secure and a little more usable, a little more controlled as to what we can do and can't do with the devices. The summary can prioritize and filter unwanted traffic, quality of service so that the phone calls aren't dropped and those sorts of things. 11F, the standard for handoffs, and then 802.11h, the standard for power over Ethernet, that allow us to manage the system. With that, I'm going to stop now, and I'd like to thank you for watching, and I hope this has been useful.